Hello everybody and welcome. Just wanted to remind you that you just need to realize there's no reason to scream or even shield your eyes because there are no lazy eyes in this calc video. And also math isn't as pressurable as, well, this. All jokes aside, let's just get started. Today I am here to introduce you to a calculus derivative taking rule called chain rule, which actually is one of the things that I enjoyed about calc. But before we start, just to let you know, there are 3 video concepts that I want you to understand. The first one is outside-inside rule, which you'll understand that it's a lot like it sounds, and it's reciprocal inside-outside rule, which I favor. And then there's the last thing that I came to realize after pondering for a little while, and an idea came to my head about a specific pyramid. No, not this pyramid. That's better. This pyramid. As I said before, inside-outside rule was my more preferred one. No different answer or easier way, but I thought let's start with it. If you remember Fog and Goff back from Miss B's Algebra 2 class, which also looks like this, f of g of x or g of f of x, it's an easy way to look at chain rule. And for this example, we're going to look at f of g of x. So as I said, we take our function, f of g of x. And since we're doing inside-outside rule, we're going to start with the inside function, which is g of x. So we take the derivative of g of x, and multiply it by the outside function, which is f of g of x. Now remember, do not change g of x to g derivative. You have to keep it the same when going with the outside function. And essentially, this is your final answer. Now, the pyramid that I mentioned earlier isn't as if it's an easier way to solve. I think of it as an easy way to check your work, but you're still doing the same thing. You count the number of functions that you have and break your pyramid in that many sections. And then you just follow through with the same inside-outside rule. And each division or chamber, section, whatever you want to call it, you multiply into each other and get that as your final answer. And if you use outside-inside rule and use this pyramid, it would be the same thing but upside down. Now, concepts aside, let's actually take figures and plug these through using inside-outside rule. So we're going to use cosine of x to the 4th minus 3x squared. And using power rule, find out that the derivative of that is 4x to the 3rd minus 6x. Now you multiply it by the outside function, which is, even though I wrote sine, remember it's a negative sine, x to the 4th minus 3x squared. And essentially this is your final answer. The only thing that you actually have to do is rewrite it with the negative in front. Now let's take a look at outside-inside rule, which, as I said before, the two rules are reciprocals of each other. So this time we're going to look at g of f of x. We start with the outside function, which is g derivative of f of x, do not change it, times the derivative of f of x, which is your inner function. And if you notice, it's the opposite of inside-outside rule. So, now we'll take an example of this, and we'll use negative sine of 3x squared minus 2x plus 1. We start with our outside function, which the derivative is a negative cosine. Even though I wrote positive, it is negative 3x squared minus 2x plus 1 times the derivative of the inside, which is 6x minus 2. Rewriting this, make sure you put a negative on the outside. It's negative 6x minus 2 cosine of 3x squared minus 2x plus 1. And that would be your final answer.